Morning, Valley Middle. Today we'll be working on lesson 3.1a, standard lesson. We've got a review, we've got a video with pause problems to take to the show. We've got 11 guided problems and 15 independent problems. Let's go ahead and start off with the review. I'd like you to do these two problems today, a multiplication of division or multiplication and division of decimals problems. So if you don't know how to multiply with the decimals, just ignore the decimals and multiply them, and I'll show you at the end. If you don't know how to divide decimals, make this 44 and leave this at 264 and just do standard division. Again, I'll teach you that at the end. All right, go ahead. These ones here are just for fun if you know them. Otherwise, I'll teach you that stuff as well. 5 minutes, folks. Go. All right, well, if you just multiply these numbers, 345 times 24, you'd end up with 8,280. Now, the way you deal with decimals is you go up and you count the number of decimals you have in the top numbers. So here's 1, 2. I have 3 decimals on top, so I go to the back of the number and I put those 3 decimals back in. 1, 2, 3. So you end up with 8.28 or 8.280, the same thing. Again, multiply straight up, just ignore the decimals and then count the decimals on top. I back them out is what I say. 1, 2, 3, and then I put them back in. 1, 2, 3. Over here, when dividing decimals, you can't have decimals in the divisor. So if you just completely ignored it and just did 264 divided by 44, you would have had 6. But if you do it with the decimals, you'll multiply this side by 10. You'll move the decimal one spot, so now you have 44. That's in the divisor. You also have to move the decimal once in the dividend. Now you have 2,640. You divide them up. You still have 6 here, but you still have that 0 to bring down. And 44 goes into 0, 0 times, so your answer is 60. Okay, these are kind of fun. What's a perfect number? A perfect number is when the sum of the factors of the numbers, except for the number itself, these are called the proper divisors, is equal to the number itself. Think about the number 6. Here are the factors: 1, 2, 3, and 6, correct? If we take out 6, because that's the number itself, and we add those up, 1 plus 2 is 3. 3 plus 3 is 6. 6 is a perfect number. There are not very many perfect numbers less than 10,000. That's how cool perfect numbers are. Google it, see if you want to figure out what they are. What's an abundant number? An abundant number is when the sum of the proper divisors is more than the number itself. So 12 is an abundant number because you do 1 plus 2 plus 3. So now here you got 6 plus 4 is 10 plus 6. So you got 16 here, and the number is 12. So this is an abundant number. A deficient number is when the sum of the proper divisors is less than the number itself. So 8 is an example of that. Here are the factors for 8. 1 plus 2 plus 4. If you add those up, you have 7. That's less than 8, so that's a deficient number. Okay? Kind of cool. Perfect, abundant, deficient. Impress your parents with the perfect number thing. All right. Sounds great. Enjoy the video. Hey, Valley Middle School. Welcome back to another math video. Tonight we're going to be working on writing algebraic expressions. Let's start off with our trivia question today. Who are these people? It's one of my favorite TV shows. I'll give you the answer to who they are when we're done with the video tonight. All right, officially tonight our target is I can write in a sentence or phrase as an algebraic expression. Let's do this thing. I'm 17 years older than arch enemy number 1, Mrs. Crothers. That's arch enemy number 1 this week. It could change and frequently does. I'll let you know if you're on the list. Write an algebraic expression for this situation using the variable c for Mrs. Crothers' age. So I want you to think about this as an expression, as a formula to find my age. Well, if you know what Crothers' age is, you could just say that whatever Crothers' age is plus 17 would be my age. This here is an algebraic expression. There's not an equal sign, but more of an expression. Mrs. Crothers plus 17 years is me. I could be your dad. That's why she calls me Grandpa or Mr. Dadley. She's such a verbal bully. All right, here are must-know words. Algebraic expression is the word tonight. We've talked about it a number of different times. It is a combination of symbols and numbers that are grouped together that show the value of something. There are no equal signs. This is 2n plus 1. This is 2 times a number plus 1. This would be a number plus 6. Do you notice how I'm taking the variable out and I'm putting in a number? Because it makes so much more sense to me. 3 times n or 3n, that doesn't mean much to me, but 3 times a number? Now I got it. A number minus 6 or a number decreased by 6. This would be 3 times a number decreased by 1. Now you're starting to get the hang of it. Let's take a look at a couple just real simple ones here, right out of the old math book. Here's an expression, write an expression for $5 more than Jennifer earned. And often they'll give you the variable too. They said, let D represent the number of dollars Jennifer earned. So here's the dollars Jennifer earned plus 5 more. So dollars plus 5. Try this one yourself. 3 more runs than the Pirates scored. Well, let's use P for Pirates. Here's the Pirates runs plus 3 more. Okay, let's keep rolling here. Let's try a couple more. Words or phrases are often used in these problems, and here's just a couple of those key words. For addition and subtraction, we got sum, more than, increased by, in all. Here's your subtraction words, difference, less than, less, decreased by. Multiplication words, each, product, multiplied, and twice. And division words, divide, quotient, per, and separate. Quotient is a really important one. Each, twice, difference, sum. These are some of the ones that kids struggle with. So keep those in mind. So let's try a couple of these here. A number increased by 3. Well, here's the number, and we increased it by 3. That means we're adding 3 to it. A number decreased by 12. Well, you can probably guess that. Here's the number, and decreased by 12. Twice a number divided by 3. Well, here's twice a number, and we're dividing it by 3. Now, we could put that 2 in with a fraction bar and 3 as well. It's another way to write it. The product of a number and 3. Product means multiplied up here. The product of a number and 3. So that's 3 times n. Most math people would write that as 3n. All right, we've worked through a number of these. Let's have you try a couple on your own here. Try these ones here. 2 times a number, 10 times a number, 1 more than 10 times a number, 3 less than 2 times a number. Pause it and try these 4. All right, let's see how you did. Well, 2 times a number is 2 times n. Math people would write 2n. 10 times a number, they'd write 10x or 10n, whatever variable you choose. 1 more than 10 times a number. So this would be 10x plus 1, or 10n plus 1. And 3 less than 2 times the number. Well, here's the 2 times the number, and here's that 3 less. Now, the order's a little quirky on that one, but it's 3 less than 2 times the number. So we have to start off with this 2 times the number first. Okay, let's try 4 more. And then we'll get to the yeah buts. So we have twice the number B, Tara's money plus 5, my weekly salary S decreased by 50, and the quotient of a number and 3. Try those. See how you did. Twice number B, 2B. Tara's money plus 5, here's Tara's money plus 5, or increased by 5. Weekly salary S decreased by 50, there's the old S minus 50. The quotient of a number in 3, here's n divided by 3. Here's where you'd probably see it written in my room. N divided by 3. I'm trying to train you that these two things here are exactly the same. All right, here's the yeah but. Yeah but 4 times a number increased by 2 is 4n plus 2. 4 times the sum of a number and 2 is going to have a set of parentheses in here. We have to do the sum of the number first. So we're taking 4 times the sum of a number and 2. And you're going to see me do that all the time. You see me do like this in class, you know what I'm talking about. Hey, when you hear the word sum or difference, there's usually a set of parentheses in there. We'll see if you can do one. These two right here. 3 times the number decreased by 2. 3 times the difference between a number and 2. All right, see if you got them. How'd you do? There, I knew you could. Alrighty, well, that's it for today. Let's get to our ticket to the show questions here. I can make this probably a little bit bigger. 3 times the number decreased by 4 is your first one. I would like you to write an algebraic expression for. The next one is Jen read 3 pages more than Bill. Let B equal the number of pages Bill read. Write a phrase to show the number of pages Jen read. Alrighty, see how you did on the old trivia question. This is Hawaii Five-0, one of my favorite TV shows. I really like these guys. Dano was was always my favorite. This was a show that was remade. It was on in the 70s when I was a kid, and that's why a lot of my family members still call me Dano. So, a little trivia about me and the show. Thanks. Have a good day. Hopefully you got your pause problems and ticket to the show done and are ready to move on. Okay, just a quick review. Algebraic expression. Combination of numbers and symbols grouped together that show the value of something. There are no equal signs. Here are 3 great examples. N plus 6. 3 times n, or 3n, and n minus 6. This would be a number increased by 6. This would be 3 times a number. This would be a number decreased by 6. All right, these phrases here you don't need to record in your notebook, but I think they're just really important. These are the things that indicate what operation we be using in when writing expressions: addition, subtraction, multiplication, or division. So I'm going to put myself up top so you can see those a little more clearly. So for addition, sum, more, increased by, or in all. Subtraction, difference, less than, less, decreased by. Multiplication, we've got each product multiplied twice or 3 times. And division would be divide, quotient, per, and separate. All right, let's go down and let's do a few problems just together. These are not your guided problems. I'll get to those shortly. 3 more than Maria's age. These are just simple ones. We'll just kind of baby step with 3. 3 more than Maria's age. Well, here's Maria's age, and it's 3 more. It's n plus 3. Twice the age of Bill, and Bill is B. There's going to be 2B. Here's twice Bill's age. 3 less than T. Well, I know you want to say 3 minus T, but that's not the same thing. This is 3 less than T. Here's T, and here's 3 less. Now, I know you're going to say, yeah, but 3 minus T. I'm just going to put it this way here. Type this down over here so you can look at it. What this really is this is 3 decreased by T, or T less than 3. We want 3 less than T, or T decreased by 3. Slight semantic difference. So be careful of those. If you have to guess, always guess that the variable comes first. 90% of the time it will be. All right, let's take a look here. I'll flip myself up so I can get up here and we can see. 3 times y plus 4. Well, just do what it says. 3 times y would be the 3y plus 4, or increased by 4. 4 times q increased by 4. Same thing. Just 4q plus 4. And then 5 times y decreased by 2. Okay? I think you could probably pass the simplified test on this right now, or quiz. But things are going to get a little more difficult. So these ones are a little more challenging. So now you got Tom's age, T, increased by 2. These are all so complicated. Tom's age, T, increased by 2. Okay, now we've got 2 increased by Tom's age. See the difference semantically? Yeah, different expressions. Most times the variable will come first. All right, 2 times Tom's age increased by 3. That one's pretty straight up. All right, these ones here, division, the word quotient freaks people out. And they stress out. They don't know what it means. The quotient of T and 3, you could write either way. T divided by 3 or T divided by 3. Okay? I like the fraction mark. The quotient of T and 4 decreased by 7. So now you've got the quotient of T and 4, so T divided by 4, and you decrease that by 7. A little more difficult. In other words, it says you take T and divide it by 4 and then reduce it by 7. Okay, 2 more than the product of Bill's age B. 2 more than the product of 3 and Bill's age B. So here's Bill's age B. And 3 times that, and it's increased by 2. This is a bizarre one. All right, upper level moves. Let me get out of the way to make room for them. These are the ones I was talking about with the parentheses. Twice the sum of Bill's age, B, and 3. Here it is. Twice the sum of Bill's age and 3. So it's just 2 times that. 3 times the difference between Bill's age B and 4. So here's Bill's age B and 4. I'm going to do that first and find that difference, and then we're going to multiply it 3 times. Okay, and this one's kind of fun. The product of 3 and B increased by the product of 2 and C. Not that hard, right? All right. These are upper level problems. All right. Let's run through some guided problems. Number on bottom left-hand corner of your paper. We should go ahead and number 1 through 11 on here, and we'll just do these. 12 more than a number. You go ahead and try it. And then I click it. I don't care what variable you use. The quotient of a number and 9. Quotient of a number and 9. Either of these would be fine. 4 times the number cubed decreased by 7. Well, here's 4 times the number cubed and decreased by 7. 15 less than a number squared. So here's a number squared. There's 15 less. 3 more than 5 times the number of dogs. Here's your 5 times the number of dogs, and it's 3 more. The product of 5 and y added to 3. Backwards. Here's 5 and y, but it's added to 3, so the 3 is first in this situation. This is kind of a fun one. 4 times the number of cows plus 2 times the number of ducks. 4 times the number of cows plus 2 times the number of ducks. These are the hardest ones, where you have to write an algebraic expression for each. So my rules on these, when you have to do these for me, is you can write the numbers out numerically. You don't always have to write them out in word form. You can if you want. And you can write out plus signs instead of writing addition or something like that, or even writing the word plus. So this is 23F. So this would be the product of 23 and F. That's one way of writing it. Another way of writing it is 23 times F. But I'm going to try to get you to use a little bit more algebraic language. This is 7 cubed, and that's really all it is, wherever it is. I guess I got to move it to find it. There it is. And 5x plus 8, what do you think that would be? Go ahead and try it. Will be the product of 5 and x, or 5 times x, increased by 8, or 8 added to that. You could do it that way as well. And this one here, kind of backwards, but this is 6 decreased by the product of 4 and y, or 6 decreased by 4 times y. Again, there's different ways of saying it, but I'm getting you to try to, my goal is to try to have you use algebraic language. All right, time for you to try some on your own. You won't have any of these ones like this. You'll just have these problems right here. There are only, there's 15, but I took 2 away because they don't match the Minnesota standards. I'm just that nice of a guy. And let me see, I guess I don't know where I'm going to go. I'll go off to the side over here so you can see them. I've also put these as a attachment onto your assignment in Schoology if you want to put it into Notability and write on there. Otherwise, you can just number 1 through 15 and cross off number 14 and do these. All right, go ahead and pause and do that. All right, I'll let you check your work on those. Okay, I'm going to slide over here. You can see why I crossed these two out. This one here had 24. We're never going to have the variable down here in the divisor position. It'll always be the variable for 6th grade math and 7th grade math in Minnesota will always be up here in, you know, the dividend position. This is like 24 divided by 6. So the number inside the house is called a dividend. And this one here is just a negative number, but it's that same goofy backwards setup. All right, very good. You should be ready to take the test. Good luck on the quiz. Sorry, quiz, not test. Thanks.